All right, in today's video, we are going to be solving right triangles, except now, instead of finding missing side lengths, we're actually going to be using trig to find angle measures in right triangles instead. So, the first part, just warm up. If you are trying to find, they're saying if A equals 8, B equals 5, we want to find C. So the easiest way that you all know is A squared plus B squared equals C squared. Oopsie, not drawing. So we'd have 8 squared plus 5 squared, A squared plus B squared, equals C squared. 8 squared is 64 plus 25 equals C squared. So then you have 89 equals C squared. And then you do your radical. And the square root of 89, using the handy dandy calculator, is 9.43. So then we just have 9.43. And by the way, it is 9.433. So because we're rounding to the nearest hundredth, that 3 tells me to just keep the 3 I have. So we'll just boop, boop, just in case. All right, so then if B equals 6 and C equals 10, we want to find the sine of B. So I'm just going to label these real quick. We're saying 6 and 10. Angle B is where our little guy is going to be standing. Boop. And so if we're doing sine, remember sine is so, which is opposite over hypotenuse. So sine B, opposite is 6 over 10, which equals 3 over 5, which you can also just write as 0.6. And then sine of 30, that's where you get to use your handy calculator. Make sure it's in degrees before we really get too started, is 0.5. And I know if you've watched the other videos that sometimes I accidentally hit the microphone. So I'm going to try and avoid that, but writing on it like this is kind of strange for me. So above, we found that the sine of 30 was 0.5. So conversely, if you know that the sine ratios of an acute angle is 0.5, you can conclude that the angle measures are 30 degrees. And this is written as arcsine. This little sine -1 is also known as arcsine or inverse sine. 0.5 equals 30 degrees. So I'll write it with this too, just so you can see it. If you notice, when you compare them, you have sine 30 equals 0.5. The ratio that they have changes its position. So instead of being sine something equals 0.5, now it's sine or arcsine of 0.5 equals 30. And then same thing, now your degree measure is your answer instead of a part of what you put into the calculator. So looking at the pictures they give us, if we have this 30 degrees, we would know that the opposite over hypotenuse would be a ratio of 1/2, so you can do like 10 over 20. And you have sine 30 equals 10 over 20. But if you have it the other way where they say, hey, this side is 10 and this side is 20, what is this missing side? Then you're going to have to use your brain a little bit. Because if you're standing there at that angle X, 10 is your opposite and 20 is your hypotenuse. So this is kind of like when you were trying to decide which trig function to use to figure out your missing side length, you're doing the same thing to figure out what the measurement is. So because it's opposite and hypotenuse, I know that that is sine. But because this is my unknown, I'm going to use arcsine, or the inverse of sine is 10 over 20, which equals my x degrees, which that would just be 30. Okay, if you put it into a calculator, you'll get the same answer. So if you know the sine, cosine, or tangent of an acute angle measure, you can use the inverse trigonometric function to find the measure of the angle. So if you have sine A, then equals x. Well, now your measurement of A is going to equal the x. Okay, so again, cosine A equals x. Now it's arc cosine x equals measure of angle A. And tangent of A equals x, then arc tangent of x equals measurement of A. Okay, and notice they do put the measurement of angle A for all of these. So when you write your answers, you'll want to have that little M with it. So first off, we're going to just use the calculator to help us find what the angle measure is to the nearest degree. That's pretty much going to be standard for this. I'm always going to want nearest degree. So we have arc cosine or inverse cosine 0.87. So on your calculator, you will probably have to do second cosine most of the time. 0.87 equals 29.54, 29.54, which again, nearest degree, if I want the nearest degree, I'm looking at this 9. That 5 tells me to push it up, so now it's going to be 30 degrees. Okay, now if you're like on the phones, the phone calculators generally don't have the inverse functions. They have these hyperbolic functions. I'm not entirely sure how to use it yet. But what you can do is if you go to your internets and you go to wolframalpha.com, spelled just like it is right there, then you can actually type in what you want. So if I'm doing arc cosine, which I disconnected my keyboard, I'm trying to see if it'll. Let's see if I can get, oh, there it goes. So you do arc cosine, and then you open your parentheses, 0.87, like we just did, close them, equals, you can go away now, keyboard. So then you can see 29.54, like I said. So this is a really good resource for you if you have a calculator that doesn't have that inverse trig functions. Then just come to this website. It's really easy to use. So going back to the notes, if I want the inverse sine or arc sine of 0.85, then that would be 58.21. So 58.21, that 2 tells me to keep my 8, so it's going to be 58 degrees. And then for inverse tangent or arctan of 0.71 would be 35.37, which again, nearest whole number, we are going to have 35 degrees, like that. So now they're going to ask it in a slightly different way. Now they're saying find measure A if sine of A is 5/6. So the easiest way is your inverse trig. So sine or inverse sine 5/6 equals, well, the inverse sine of 5 divided by 6 is 56.44. So the nearest degree would be 56 degrees. Let's make my 6 look like a 6 though. 6. There we go. We want to find the measure of angle M if cosine M is 11/17. So inverse cosine 11/17. And again, this is a lot of calculator work. So if you don't have a scientific calculator that can do it, or whatever the case may be, just make sure you're looking at it. So I wrote extra decimal places because the numbers were big, but 49, I really only need that 6. That tells me that I'm going to round up to 50 degrees, because again, nearest degree. If tangent of x is 0.643, I'm going to use my inverse tangent to help me. So tangent 643 equals, again, popping it into the calculator, 0.643 is 32.74, which to round, that 7 tells me to go up, so it's 33 degrees. Okay, and then last but not least, sine y equals this long decimal. Don't round, just type it in. It's not going to kill you. So inverse sine of 0.587785 equals inverse sine. Let me type it in. Gives you 35.99999. And it's just going to keep going. So because it's 35.999, that tells me to round up to just 36 degrees, like that. Okay, so notice when we did this, all we did was plug it into the calculator. We took the ratio that they gave us and we plugged it in with the inverse instead. Okay, so now we're going to be given a trig ratio and we want to figure out which angle of the triangle is it talking about. So if I have sine of A, by the way, our options are angle 1 or angle 2. We'll see. So if I have sine of 4 over 5, looking at these side lengths, I have 8, 6, and 10. So 4 over 5, if I multiply them both by 2, would give me 8 over 10. So we got to use SOHCAHTOA. Remember, I told you it's going to be your new best friend. So because we have 8 over 10, we know that this is the hypotenuse, so that doesn't matter. But we know we're using sine, and with sine, we know we need our opposite and our hypotenuse. So because we have the 8, I know my 8 has to be my opposite side. So opposite of the 8 is, ding, 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 angle 1. Okay? So now we look at the next one. We'll erase these. Well, I'll keep the hypotenuse because that doesn't change. But they're doing tangent of 1 1/3. Again, you might have to adjust these a little bit. 1 1/3 isn't very friendly, but we can make it an improper fraction. 3 times 1 is 3, plus 1 is 4. So we have 4/3. And 4/3, because none of my sides are 4 or 3, we'll just multiply them both by 2. We'd have 8 over 6. This is tangent, which tells me I need my opposite and my adjacent. So because tangent is opposite first, I know my opposite side has to be the 8, and my adjacent side is the 6. Okay, so then because I need opposite over adjacent, the only thing that's opposite of that 8 again is ding, 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 angle 1. And 6 is right next to angle 1, so that makes sense. It works out. Okay, so then we do it again. We have cosine of A is 0.6, which can be written as 6 over 10 because it's 6/10. Remember, that's the 10th place. So because it's cosine, we know it's adjacent over hypotenuse. So my 6 is my adjacent, and the 10 is still the hypotenuse. So because I'm doing cosine and my adjacent is 6, that tells me the angle next to the 6 is, ding, 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 angle 1 again. So now we have all of the trig functions for angle 1. So chances are the rest of them are all going to be angle 2, but we'll double check just to make sure. So we have cosine of A equals 0.8, which would be like 8 over 10. Cosine is adjacent over hypotenuse. So my adjacent is 8. And my hypotenuse is still 10. So because it's 8 over 10 and it's cosine, the angle that is next to the 8 is angle 2. Okay, so now let's do blue. Now we have tangent of A, which is opposite over adjacent, is 7.5 or 0.75. So that would be 3/4 as a fraction, or 6 over 8 if we want to use our side-friendly measurements. So because it's 6 over 8 and we're doing tangent, which is opposite over adjacent, my opposite is 6. So 6 is opposite, adjacent is 8. So the only thing that's opposite of the 6 is angle 2. And then 8 is right next to it, so it makes sense. The nice thing is if you can identify like your opposite or adjacent, it's generally pretty straightforward to figure out, which trig function you're going to use. Let me rewrite my TOA. There we go. All right, so last but not least, we have yellow. Sine of A is 0.6. So again, that's like 6 over 10. And again, sine is opposite over hypotenuse. So my opposite is 6. And the only thing opposite of the 6 is angle 2 again. So notice when I did this, it was a lot of, well, I know my side is opposite, I'm going to the opposite angle. And just kind of working backwards with your trig functions. So using given measures to find unknown angle measures and side lengths of a triangle is known as solving a triangle. To solve a right triangle, you need to know 2 side lengths, or they might even just give you an angle and a side length, kind of depends. So the main thing with this is anytime they ask for this, you have to find all of the missing things. So I don't know what angle R is. I don't know what angle T is. And I don't know what this ST is, the length of it. So we're going to start with the measure of angle R. So looking at R, if I'm a little guy standing over here, okay, 5 is my adjacent side, and 5.7 is my hypotenuse. So looking back at your trig functions, remember SOHCAHTOA, the only thing that has adjacent hypotenuse, A and H, is cosine. So we would have cosine of x equals adjacent over 5.7, right? But oh no, we don't know our angle measure, and that's what we need. So that's your hint right there that you're going to use the inverse. And notice all you really do is you erase the x, and you put it on the other side. So cosine -1, 5 over 5.7 equals x. So inverse cosine, oops, calculator turned off, 5 divided by 5.7 is 28.69, but again, nearest degree, 28.69. That 6 tells me to round up, so it's going to be the measure of angle R equals 29 degrees. Okay, so now if I go to find what the measure of angle T is, now I'm over here. Well, now if I'm over here, now 5 is my opposite side and my hypotenuse. So because we're looking for opposite hypotenuse, that would be sine. But again, we're looking for an angle measure. So because we need the angle measure, we know we need inverse. So inverse sine 5 over 5.7 equals x. And the inverse of sine of 5 divided by 5.7 gives you 61.31 when you round. But I only care about my tenths place. That 3 tells me to keep it. So my measure of angle T equals 61 degrees. And these two numbers here should add up to 90. And 61 plus 29 is indeed 90. And then if you think about it, those two angles here and here plus my other 90 would give me 180. So that triangle addition postulate still works here. So to find the length of ST, you can either use trig again or you can use the Pythagorean theorem. It doesn't really matter which one you use. Generally speaking, I tend to use trig just because I like trig, but you can use the Pythagorean theorem too. So we'll do it both ways. If you did it with the Pythagorean theorem, you'd have 5 squared plus b squared equals 5.7 squared. So you'd have 25 equals b, oops, not equals, 25 plus b squared equals 5.7 squared, 32.49. Then when you subtract the 25, you get that b squared equals 7.49, and then the square root of that gives you b approximately 2.736, and that 6 rounds up to 2.74. So that's using Pythagorean theorem. If I used trig, I would just have to pick one of the angles. So let's say I picked angle T. Still going to look from that angle. Angle T is 61 degrees, and ST is adjacent to that. So then that would be cosine. So cosine of 61 equals adjacent that I don't know over 5.7. So then you'll multiply both sides by 5.7. And 5.7 times the cosine of 61 gives us 2.76. So notice they are super close. Chances are it's just because of some rounding stuff, like this 61 technically is a decimal, is 61.31. So that rounding does change it a little bit. And just out of curiosity to check it, if I do the cosine of 61.31, I get 2.736 again. So it might not be a bad idea if you do use trig to just plug in your decimal form of the degree measure, or you can use Pythagorean theorem. Either will work. So just note, use decimal form for measure of angle. To get 2.736. Okay, so again, use the decimal form if you want to get the most precise answer, the same answer as Pythagorean theorem. But either way, it'll work out. So we're going to solve this right triangle. We need EF, FD, and angle D. Oopsie, go away. So finding angle D is actually kind of the nice one. So measure of angle D, EF, and FD. So if I'm looking for the measure of angle D, I already know one of my angle measures, so I can actually just subtract from 80. So 180 minus 90 minus 58 equals 32 degrees. So the measure of angle D equals 32 degrees. Okay, and that one's pretty straightforward. My F looks funny. So if I want to find EF and FD, I would probably base it off of the 58 degrees because it was already given to me. So that would make the 14 opposite and the EF adjacent and then the hypotenuse. So using SOHCAHTOA, to find EF, I would need my adjacent and my opposite. So because I need adjacent and opposite, that would be TOA. So tangent of 58 equals opposite over adjacent. Multiply both sides by x to cancel it out. And then divide by the tangent of 58. So then 14 divided by the tangent of 58 is 8.748. And actually I'm going to change this to EF. And they want to the nearest hundredth. So it's 7.748. So because of that 8 right here, we're going to have to round up to 0.75. Okay, and then for FD, we're still going to use our opposite, but now we're going to find our hypotenuse. So opposite and hypotenuse is sine. So sine of 58 equals opposite over hypotenuse. And you have the exact same steps. Multiply by x and divide by your trig function. So you'll notice that you don't always have to use the inverse trig functions. It's only sometimes, and it's only when you need to find that angle measure. So that's 16.508. So 508, the 8 tells you to round up. So now my 0 is 5.1. Okay, and we found all the missing stuff. So our next example, we're doing the exact same thing, but using different numbers. So looking at what I don't know, I do not know the measure of angle B. I also do not know the length of AC or the length of BC. So to do that, use whatever trig or math rules you remember. So angle B, we have 2 angle measures in this triangle that we know. So that makes our life easy. We can do 180 minus 90 minus 75, which tells me that the measure of angle B is 15 degrees. Done. Nice and easy. For AC, let's change to pink. AC is this side on the left. Again, I try and focus on using the same angles that they give me for sure. So since this is a 75, I want to base it off of this angle up here. So if I'm basing it off of the 75, AC is my adjacent. I'm not saying you can't use angle B. That would also be fine, but just being aware of your options. So if we use that, we have adjacent and hypotenuse. So using SOHCAHTOA, if you haven't already written it 1,000 times, adjacent and hypotenuse is cosine. So we would have cosine of 75 equals adjacent, that I don't know, over my hypotenuse, which is the square root of 6. So then you multiply by the square root of 6 on both sides, and you get square root 6 times cosine 75 equals x, and square root of 6 times cosine of 75 equals 0.6339. So 0.63 is AC. Okay, and that makes sense because this is a right triangle. My hypotenuse should be longer than all my sides, and the square root of 6 is about 2-ish. So it makes sense that it's not a very big number for AC. So then to find BC, we are going to do basically the same thing, except BC is now our opposite of 75. So because it's opposite in hypotenuse, now you'd be using sine. So sine of 75 equals opposite over hypotenuse. And then you'll multiply by square root 6. And square root 6 times sine of 75 is 2.366. So because we have 2.366, we're going to round up to 2.37. Like that. Okay? So just keep in mind, you're still using the same rules for trig functions. There's nothing really new about that. But just make sure you take your time and know which trig function you're using. So we have an actual application. A highway sign warns that a section of a road ahead has a 7% grade. To the nearest degree, what angle does the road make with a horizontal line? The 7% grade thing, which I did not know this until today, the 7% grade means the road rises or falls 7 feet for every 100 feet of horizontal difference. So you need to change the percent grade to a fraction. So we have 7 over 100. Okay, so they just want to know angle A. What is the angle that is formed with the hill? Right? So if we're looking at angle A, 7 feet is opposite of that, and 100 feet is adjacent. So looking at your trig functions, the only one that's going to give me opposite and adjacent is tangent. But remember, my unknown is an angle. So if my unknown is an angle, you're going to have to use the inverse function. So inverse tan or arctan is opposite over adjacent. So opposite is 7 over adjacent is 100. And what does that equal? We don't know. So measure of angle A. This is where you use your handy dandy calculator. Again, it's wonderful. Arctan of 7 over 100 is 4.004, but they want the nearest degree, so it's just going to be 4 degrees. Okay, simple as that. All right, and then our last one, Baldwin Street in Dunedin, New Zealand is the steepest street in the world. It has a grade of 38%. To the nearest degree, what angle does Baldwin Street make with a horizontal line? So this is probably another time for you to draw yourself a cute little picture. This is the street up here. Okay, so this street probably was way steeper than this. That 38%, remember, tells you that it rises or falls 38 feet vertically for every 100 feet horizontally. So we have 100 feet horizontally. and 38 feet vertically. So then if we're looking at the fact that we're looking at this angle, I know my opposite and my adjacent again. Actually, let's do orange. And adjacent. So again, you're using sine, cosine, or tangent. Because I am given opposite and adjacent, I know I'm going to need to use tangent. But because my unknown is in degrees, I'm going to use the inverse tangent or arctangent. And by the way, if you want to write it with the arctangent or arcsine, that's fine. It would just be like that, okay? Or you can write it like that, totally up to you. But since you've been using the inverse way, I'll keep using it. So inverse of tangent, we know the ratio is 38 over 100 because it's opposite over adjacent equals the measure of angle A. Okay, and you can write x2 instead. It's kind of up to you. I just like to write measure of angle A because I know I'm just going to type it straight into a calculator and don't have to do anything fancy. So I get 20.8 and 20.8 if I'm going to the nearest degree. That 8 tells me to round up. So I know the measure of angle A is 21 degrees. Okay. Now, you have some homework. The homework is going to cover quite a bit. There's some that you'll have to actually graph. So just remember, if you are finding angle measures, use your inverse functions. And that may mean you're still going to use the same rules for, like if it's opposite over hypotenuse, you're still going to use sine, except it'll be the inverse sine. If you are finding side lengths, just use regular trig. Or Pythagorean theorem if you can. Okay, and your other option with inverse trig for finding angle measures is to use the subtract from 180. If possible. Okay, so you should be set to go. If you have any questions, you can either leave a comment or email me directly, kind of up to you. Hopefully this video was helpful. Don't forget, if you don't have a calculator that is friendly to inverse trig functions, Wolfram Alpha is probably going to be your best bet, although you may be able to just copy and paste into Google and see what happens. So hopefully I covered anything. Let me know if I need to clear anything up. Happy working!